Hello, in this lesson we will talk about mathematical induction. What is a mathematical induction? This is a method of providing that a statement, assume we have a statement f of n is equal for 0. This statement can be equality, it can be inequality, for example. It doesn't have any meaning. Is it equality or inequality? Assume this is equality, and if we want to prove that this equality is correct for any n, say more than 1, it can be more than 2, it can be true for any n, and we want to prove it, we can use a very effective technique in math, which is called mathematical induction. For this, we have to, first of all, check the base of induction. This is called the base of induction. It means that we have to check this equality or inequality, this equality for some initial n, say for n 1. We check that f of 1 is 0. We can also check that f for 2 is 0, and that's all. This is the base of induction. So we checked the correctness of our equality for some initial number of n's for n when n is 1 and 2. Next, we have to check that if f of k is equal to 0 is correct, then is it true? We have to check this. Is it true that this is correct also for f of k plus 1? So if we prove this, in this case, of course, our initial result, this is our initial result, will be correct for any n. Why is it so? If you have experience in programming, you can assume that here the first step, this first step, f of 1 is correct, f of 2 is correct, and since we prove that this is true, it will be f of 2 is correct, and using this result we see that f of 3 is correct also, and again using this result f of 4 is correct, and so on and so on, and f of n is 0 for any n. And this is the technique in math is called mathematical induction. Once again, to prove that some statement, for example, f of n is equal to 0 is correct for any n, first of all, we check the base of mathematical induction and check that f of 1 is correct, f of 2 is correct. Next, we show that if we have that f of k is correct, assuming that f of k is correct, we have to show that f of k plus 1 is correct. In this case, everything will follow from this statement, and we will have that f of 2 is 0, f of 3 is 0, f of 4, and f of n for any n is 0, which is our initial statement. Let's give an example of mathematical induction. Assume we have a formula 1 plus 2 plus 3 plus and so on plus n is equal to n plus 1 times n divided by 2. And assume we want to prove, is this formula correct for any n? Of course, this formula is correct. And how can we prove this formula? This is formula which is actually first implemented and used by Gauss when he was very young at school, actually. So we add these two elements and we will have n plus 1, of course. And here we have n minus 1, here we have n minus 1. And if we add these two elements, we also have n plus 1 and so on. So we have n plus 1 n over 2 times. And this formula, of course, we can prove it very easily. But anyway, assume we want to prove this formula for any n. To prove this using mathematical induction, first we prove that the base of induction is correct. The base of induction is correct. We check it for n 1, so we will have 1 is equal to 1 plus 1 times 1 divided by 2. So the both sides will be 1. It will be 1. 1 is equal to 1. So our formula is correct for n, which is 1. Let's check it for n, which is equal to 2. We will have 1 plus 2 is equal to 2 plus 1 times 2 divided by 2. And from both sides we will have 3, and here, of course, we also have 3. So the base of induction is correct, and let's assume that this formula is correct for assume formula is correct or is true for k. For k, assume we have 1 plus 2 plus 3 and so on plus k is equal to k plus 1 times k divided by 2. Assume this is correct. So this is correct. Is it true? Is it true that is it true for k plus 1? Is it true for k plus 1? Is it true that 1 plus 2 plus 3 plus k plus 1 is equal to k plus 2 times k plus 1 divided by 2? Is this correct? So if we prove this, we are done. Let's begin to prove this result. We will write that 1 plus 2 plus 3 plus and so on plus k plus 1 is equal to, from our assumption, this 1 plus 2 and so on plus k is equal to k plus 1 times k divided by 2. Let's write it. This is equal to k plus 1 times k divided by 2. And rewrite the last term, k plus 1. K plus 1. Let's rewrite it again as in denominator we will have 2, in numerator we will have k plus 1 times k plus 1 times 2. And it will be equal to we will take k plus 1 out, and we will have k plus 1 times k plus 2 divided by 2. But this is what we needed. This is what we needed. This is what we wanted to prove. Once again, to prove this formula, where is it? To prove this formula for any n, we checked the base of induction, that this is true for n plus 1, that this is true for n plus 2. Next, we assume that formula is true for k. We have this, assume this is true. And let's check that this is true. And we checked that this is true, and this is equal to k plus 1 times k plus 2 divided by 2. So this formula, we proved this formula, and our initial formula is correct. So 1 plus 2 plus 3 and so on plus n is equal to n plus 1 times n divided by 2. Thank you very much.